My name is Yuva, and I'm here today to talk about using SeLion for web automation. In the next few minutes, you will learn how to use SeLion for automating web flows and also some interesting know-hows which makes web automation a fun experience. So let's get started. SeLion uses Selenium internally to interact with browser and to drive the UI action on web pages. In the due course, I'll be introducing about a new annotation called @webTest annotation. This annotation is specific to CLine, followed by the abstract elements in CLine and the ease of switching between browsers, followed by EC debugging. So let's get started with our example. So the example test class which I'll be using in this demo is demo web test, and the suite file name is sample_suite_ui.xml, which contains the test that needs to be run and also some specific parameters which I'll be explaining now. Let's look at the test class. So this is my test class which is going to interact with the Google page. I have two test cases, test Google page and interact with Google page. The interact with Google page depends on test Google page. So what's so new about this? There's a new annotation called @webTest, which is a way of telling CLine that this particular test method is a UI test case. So whenever this test method is launched, there should be a browser open for it to interact. For now, I'll just disable this test method and let's just run only the test Google page. So I'll run the test institute. So this will open up a Google page, load the Google URL, and it will log the title. So what you just saw is a browser was open, it loaded the page, and it printed the title. But where do I look for the information? Whenever a CLine test is run, a test report will be generated. So this is the CLine runtime reporter. It will be loaded dynamically as and when the test scripts are run. So when I hover this uh, test detail, it shows the status as passed and it also shows start time and end time. And when I go further and click on the reporter output, it shows the test name followed by the screenshot and also the source. So how it was made possible. Here, when I loaded the URL and once I read the title, I am instructing CLion to use the CLion reporter and log the title along with the screenshot of the page and also the source. Once I did that, I've just closed the web page. So this is just a sample case of running a UI test using CLion. Things to note here are the @webTest annotation and the grid.driver.get followed by the CLion reporter. Let's move on to understanding the parameters that are required to run the web automation in CLion. If you take a closer look at the suite file, along with the test class details, I've specified the parameters like browsers, run locally, and Chrome driver path. Let's focus on the browsers and run locally first. So whenever a web automation is run using CLion, SeLion provides you an option to switch between browsers by setting this parameter in your suite file. Right now, I've specified the option to be Chrome. In a Selenium world, to run test using Chrome, you require the Chrome driver on your class path. So in addition to specifying the browser as Chrome, I've also specified the Chrome driver path. This is not necessary in case of Firefox browser. The next parameter is the run locally. Whenever uh, CLine is used for web automation, before running test cases in a CI environment, any user will be doing local runs. So in order to spawn a browser locally, this parameter should be set to true. By default, this will be set to false. And if at all if a Selenium grid is not provided, then CLion will throw an exception. This option can also be specified as a VM argument like -d CLion underscore selenium underscore run underscore locally equal to true, and this option can be given in a command line for Maven. These options are called config parameters in CLion, and these are available in clion.io. Now let's flip the browser to Firefox and see what happens. So instead of a Chrome, a Firefox is launched and the same test will be run in Firefox. Now, before looking into the next test method, let's pause a bit to understand how UI actions are done from a test case. To do so, let's revisit the concept, or let's understand the concept of locators. In a Selenium world, to drive UI actions, locators are used to identify the elements on the web page. It can also be called as pointers to web elements on HTML page. Say for example, if there is a text field or a button on a web page, it will be designated with a locator which can be provided to Selenium and which in turn will find the element using that locator. A locator can be specified using ID, name, link text, XPath, CSS, and class name. So if by any chance if the locator is not found, then element is said to be not found and an exception will be thrown. So this test case will be interacting with the Google page by typing some random search text in the text field and in turn will click the search button. In a Selenium world, every element on the web page is a web element located using the locator. But in case of CLion, let me introduce abstract elements. These elements map to the web elements on the web pages. For example, a text field will be mapped to a text field, whereas in Selenium world, it's just a web element. It has been done so because whenever a failure happens, from the Selenium, all we get is a locator and a no such element exception. By mapping these web elements to class names such as text field, button, radio button, checkbox of abstract element type, it will be clear as to which element was not found on the web page. So when interacting with the Google page, to type anything into a search field, it is a text field. And I've specified the locator as id equal to lst-ib. Please note that in SeLion, a locator with ID, name, XPath, CSS should be prefixed with ID equal to or name equal to or CSS equal to or XPath equal to. The next one is button. Once I've typed the text in the search field, I'll be clicking on the search button. So I've defined it as button. So let's get started on interacting with the Google page. As usual, I'll be loading the URL using grid.driver.get. And once the page is loaded, I'll be typing the text CLine followed by, now once I typed it, the page will get refreshed automatically showing the test results. So I'll have to wait for the search button. And once it is found, I'll be clicking. Please ignore this thread.sleep. I have included this for illustration purposes alone. In case if you are waiting for any elements to be present, to be visible, or until any text present, please take a look at the WebDriver waitUtils class. This class internally contains Selenium weights, which are more appropriate for web automation. So once I've searched for CLion, I'm clearing the text and again I'm searching for Optimus Prime. Once that is done, I'm taking a screenshot. Now let me run this entire suite. So what happens? A Firefox instance will be opened. It will load the Google page. It will get the title and it will close, followed by another Firefox instance, which will again open the Google page, type the CLion, it will clear, and then it will type Optimus Prime. Now this entire set of UI actions will be run in a fast manner, which you may not be able to notice the flow. In such cases, you can always log it into the screenshots and you can view it. Now let's take a look at the report. So there are two test methods which I have run now from the suite CLion sample test, from the test demo web test. If I click here, as I showed you previously, it will contain the same details. Now let me click the next link. It will contain a screenshot of the two search results. So what happens when I just flip the locator to a wrong locator and interact with the page? For now, I'll just disable this. I'll uncomment this and let me run the suite. So it load the google.com URL, but when typing, it won't be able to find that element. So a no such element exception will be thrown. So in doing so, Selenium just gives you this raw message stating that no such element exception of that uh, type ID and its locator is so and so. But whereas if you go down through the stack trace, you can always click on the test case. It will take you to the control name. In this case, it is search field or type. It is very sure that the search field is a text field for which the locator has changed or needs to be reconciled. So this is one primary advantage of using abstract elements uh, in CLion. More of it will be covered in the code generator section. Now that you have seen a practical walkthrough of how to get started with web automation using CLion, so let's just pause things a bit and have a checkpoint on some of the things to remember while actually using CLion for web automation. The first thing is the test method you have for the UI flow should be annotated with @webtest, then followed by proper locators. This locator can be found by right-clicking on the respective element on the web page, choosing inspect element, which will then take you to a page source where you can get the locator. The next one is any call to the driver should be through the grid.driver. The next one is, so whenever the UI automation goes through multiple pages, it is wise enough to add waits so that the element is interacted only after it is loaded. The next thing is use logger wisely. Don't log every piece of information into the logger. Log the information only which you want to see so that it will be helpful for debugging purpose. And finally, use grid.driver.quit cautiously. When you call a quit, it will actually close a browser and it will invalidate the current session. I hope that this video was helpful to get started with web automation using SeLion. For more information, you can always look at http://clion.io. And if you have any further questions, you can post it to us in our SeLion forum. Thank you.